So we discussed about thermodynamic chapter. In the chapter, we are going to discuss about laws of thermodynamics. In this topic, we are going to discuss what are the laws, zeroth law and first law of thermodynamics and second law, and various thermodynamic processes of first law. So these are the main topics today we discussed about in the chapter. So first of all, you have to see in the slide clearly. Or in this slide, laws of thermodynamics, that is the first one is the zeroth law. Second one is the first law of thermodynamics and isothermal process, adiabatic process, isobaric process, isochoric process. These are all we are discussed already. Now we are going to work done in various thermodynamic processes. In this, first one is the irreversible expansion. In the what is the irreversible expansion? That is the relation between pressure and volume. That is depends on. So what is the mathematical equation of this one? W is equal to minus negative sign of P external delta V. Here pressure is decreased, the volume is increases. That is the irreversible expansion. For irreversible expansion, W is negative sign of P external delta V. W is equal to work done by the system. P external pressure. Delta V is the increase in volume. So that is the irreversible expansion. Next one, reversible expansion. What is the reversible expansion? Isothermal reversible expansion of ideal gas equation. What is the isotherm? Isothermal at constant temperature at constant temperature in reversible expansion that deal with ideal gas equation. So you take first law of thermodynamics. What is the first law of thermodynamics? Q is equal to delta E plus P delta V. Q is equal to delta E plus P delta V. But P delta V is equal to negative sign of W, that is work. So Q is equal to delta E plus minus W. In isothermal process, energy is 0, that is constant. So Q is equal to minus W, or Q is equal to P delta V. So minus W is equal to P delta V. Then it apply in ideal gas equation. What is the ideal gas equation? PV is equal to nRT. You have to substitute the first equation, that is minus dW is equal to P delta V in ideal gas equation. So you get minus dW is equal to nRT by V dV. What is the ideal gas equation? PV is equal to nRT. So P is equal to nRT by V. Then it from 1 and second equation, minus dW is equal to nRT by V dV. Upon integrating equation 3 by integrational equation, integration of minus dW is equal to nRT integration of dV by V. Here lower limit is V1, upper limit is V2. Minus W is equal to nRT ln V, the integration value ln. So minus W is equal to nRT ln V. So again I repeat, what is the isothermal reversible expansion of ideal gas equation? From first law of thermodynamics, Q is equal to delta E plus W. Here delta E is equal to 0. Q is equal to minus W, that is P delta V. Minus W is equal to P delta V. Then it apply in ideal gas equation, that is equal to PV is equal to nRT. P is equal to nRT by V. So from 1 and 2 equation, minus dW is equal to nRT by V dV. Then it undergoing integration, we got minus W is equal to nRT ln V. nRT ln V. So this one is the first slide of the isothermal equation. Next, second, then continuation is minus W is equal to nRT ln V2 by V1 minus W is equal to nRT 2.303 log. Ln converted into log values. Ln is equal to 2.303 log V2 by V1. W is equal to minus 2.303 nRT log V2 by V1. That is the volume equation. What is the volume equation for work done in isothermal process? W is equal to minus 2.303 nRT log V2 by V1. From Boyle's law, PV is equal to constant. What is the Boyle's law? V is inversely proportional to 1 by P. So P1 V1 is equal to P2 V2. P1 by P2 is equal to V2 by V1. In terms of pressure, W is equal to minus 2.303 nRT log P1 by P2. Work done in isothermal reversible compression, W is equal to 2.303 nRT log V2 by V1 and W is equal to 2.303 nRT log P1 by P2. This is the equation for the pressure. So again I repeat, minus W is equal to nRT ln V2 by V1 volume. It converted into log values. Minus W is equal to 2.303 nRT log V2 by V1. Then it applies Boyle's law. What is the Boyle's law? PV is constant, that is V is inversely proportional to 1 by P. So P1 V1 is equal to P2 V2. P1 by P2 is equal to V2 by V1. In terms of pressure, W is equal to minus 2.303 nRT log P1 by P2. Work done in isothermal reversible compression, W is equal to 2.303 nRT log V2 by V1 and W is equal to 2.303 nRT log P1 by P2. So this is the equation, isothermal reversible expansion of Adiabatic equation. These are the two equations. So what are they? First one is the volume, second one is the pressure. What is the volume equation? W is equal to 2.303 nRT log V2 by V1. As per pressure, W is equal to 2.303 nRT log P1 by P2. So next one is the adiabatic reversible expansion. Adiabatic reversible expansion. For this process, Q is equal to 0. From first law of thermodynamics, Q is equal to delta E plus W, delta E plus P delta V. But Q is equal to 0. So 0 is equal to delta E plus P delta V. That is equal to delta E plus minus W. W is equal to delta E. But delta E is equal to CV dt. That is important. Delta E is equal to CV dt. That is equal to delta E is equal to CV dt. So W is equal to CV dt is equal to CV of T2 minus T1. But Cp minus Cv is equal to R. Dividing equation 1 by Cv. Cp by Cv minus Cv by Cv is equal to R by Cv. So Cp by Cv is equal to gamma minus 1. Cv is Cv. Cv by Cv is cancelled, that you got 1. So gamma minus 1, that is equal to R by Cv. Cv is equal to R by n minus 1. W is equal to R by gamma minus 1. That is T2 minus T1. Negative sign. Gamma is equal to position ratio, Cp by Cv ratio. T1 is equal to initial temperature. T2 is the final temperature. For expansion, T1 is greater than T2. For adiabatic reversible compression, W is equal to R by gamma minus 1 T1 minus T2, or W is equal to minus R by gamma minus 1 T2 minus T1. T2 minus T1. So again I repeat once this one. What is the adiabatic reversible expansion? For this process Q is equal to 0. From first law of thermodynamics, Q is equal to delta E plus minus W delta E plus P delta V. But Q is equal to 0. 0 is equal to delta E plus P delta V. That is equal to delta E plus of minus W. W is equal to delta E. But delta E is equal to CV dt. So W is equal to CV dt. Here T, take it as T2 minus T1. You know, Cp minus Cv is equal to R. Dividing equation 1 by Cv, Cp by Cv minus Cv by Cv is equal to R by Cv. Cp by Cv, his value is gamma. Cv by Cv is equal to 1. Therefore, gamma minus 1 is equal to R by Cv. Cv is equal to R by gamma minus 1. So, W is equal to R by gamma minus 1, T2 minus T1. Gamma is equal to ratio of Cp by Cv. T1 is the initial temperature, T2 is the final temperature. For expansion, T1 is always greater than T2. For adiabatic reversible compression, W is equal to R by gamma minus 1 T1 minus T2, or W is equal to minus R by gamma minus 1 T2 minus T1. Next one is work done in cyclic process. You see in slide clearly, work done in cyclic process. During cyclic process, the change of any thermodynamic function is 0. That means they remains constant. Delta E is equal to delta H, that is equal to delta G, that is equal to delta A, that is equal to delta S, total 0. Delta E is internal energy, delta H enthalpy, delta G Gibbs energy, delta A entropy, delta S is equal to 0. From first law of thermodynamics, Q is equal to delta E plus of minus W, work done by the system. But for cyclic process, delta E is equal to 0, Q is equal to 0 plus of minus W, Q is equal to minus W, W is equal to minus Q. Work done in clockwise cyclic process is taken as negative, and in anti-clockwise cyclic process is taken as positive. So, what is the work done in cyclic process? During cyclic process, see in slide clearly, the change of any thermodynamic function is 0. The change of any thermodynamic function is 0. So, during cyclic process, the change of any thermodynamic function is 0. That means they remains constant. Delta E is equal to delta H, that is equal to delta G, that is equal to delta A, that is equal to delta S is 0. First law of thermodynamics, Q is equal to delta E plus of minus W. But for cyclic process, delta E is equal to 0. Q is equal to 0 plus minus W, Q is equal to minus W, W is equal to minus Q. Work done in clockwise cyclic process is taken as negative, and anti-clockwise cyclic process is taken as positive. Work done in free expansion. Free expansion is an expansion of the gas which is taking place against 0 external pressure. P external is equal to 0. W is equal to minus P external delta V, that is equal to 0 delta V. So W is equal to 0 at work done in free expansion. Work done in free expansion is What is the equation? W is equal to 0. So today class we are to discussed about what are the irreversible expansion, what is the irreversible expansion, and what is the mathematical equation. W is equal to minus P external delta V. Next, isothermal reversible expansion of ideal gas. Here two equations are there, one with volume, second one with pressure relation. What is the volume relation? W is equal to minus 2.303 nRT log V2 by V1. With pressure, W is equal to minus 2.303 nRT log P1 by P2. P1 by P2. In adiabatic reversible expansion, what is the mathematical equation? W is equal to minus R by gamma minus 1 T2 minus T1. That is the equation. Next, in work done in cyclic process, all are is 0. That is equal to W is equal to minus Q. That is minus Q. Work done in free expansion. Work done in free expansion. That is W is equal to 0. That is equal to W is equal to 0. So, in this chapter, we have discussed clearly in thermodynamic chapter basic terminology and thermodynamic functions and relation between delta H and delta E. Delta H and delta E. What is the relation? Delta H is equal to delta E plus delta nRT. Delta nRT. Heat and heat. What is the thermodynamic process? What are they? Isothermal, adiabatic, isobaric, isochoric, cyclic processes. Next one is the law of thermodynamics, zeroth law, first law, isothermal process, irreversible and work done. So today class we discussed about this one. Tomorrow we discussed about heat capacity and the relation between Cp minus Cv and Joule-Thomson effect. Joule-Thomson effect. These are the main important topics in this chapter.